Now let's move on to the rest of kind of the topics today, which are a lot faster than the first one. And so we're going to talk a bit more practically about how to use modern AI, right? And how to kind of think about it. The first thing is that there are a lot of different AI models, right? So hopefully you've heard of some of these names before. These are some of the biggest commercial models that one can use. And these are the big open source models that you can use as well. And they all have kind of their different quirks, their different characters. And so we'll talk a little bit about each one in the following slides. Now, I was talking about this before, but this black line here represents proprietary closed source models, so ones that you have to pay for their performance. And this blue one represents open source models, right? And you can see how kind of the race between commercial and open source models has been very thin for a while and arguably is kind of nearing, kind of being very close in recent times, right? So open source models are catching up very quickly to commercial models, which makes it harder, as you can imagine, for OpenAI or Anthropic to kind of justify pouring in billions of dollars if a company can just merely replicate their results kind of within a few weeks, right? So kind of very difficult to do that. Now, which kind of model do you want to use, right? And this is always kind of shifting. Like the kind of advice I gave for this last year would be different to now. But for commercial models, you want to use a commercial model if you want to start a project very rapidly, right? So it's very easy to connect to like OpenAI or Claude. It allows you access to the latest models. So you do end up having the best models, right? As you're kind of running through, but usually only by a few weeks these days. And it costs more. And the kind of downside is that it costs more if the model is used significantly. So kind of in our lab, a general rule of thumb that I have is that if we're planning to use kind of more than $1,000 of compute, we should be switching to an open source model, okay? For open source models, generally they have higher upfront time and cost just because you have to do some setup, although it is getting a little bit easier with things like OpenRouter or DeepSeek. It allows you to fine tune. So I kind of made this distinction yesterday. If you want to modify the weights of the model, open source models, you must use open source models in order to be able to fine tune. It also allows on-site compute. And so why this is important is that if you end up doing like a medical research project and, for example, work with data in a hospital, a lot of hospitals in Australia will require you to do on-site compute. And I believe this is very similar in a lot of different countries as well, okay? So a lot of hospitals will mandate that you will use an open source model if you want to do something with a hospital, okay? Now, in terms of commercial models, the kind of default that a lot of people kind of think of when they think of AI is OpenAI. And there are basically two models that you can use. One is non-thinking and one is thinking. Okay, so thinking just means that it will reason through the problem, while non-thinking means that it will just kind of spit out an answer immediately. And so it depends on the circumstance in which you want to use these models. So obviously if you're thinking of, I don't know, like a medical problem or kind of like a research problem or something, you of course want a thinking model. But if you want just like a bunch of facts, like something that you'd look on Wikipedia for, then you kind of want a non-thinking model because it's a lot cheaper, right? The model won't overthink the question. OpenAI has also built their kind of chat interface to decide. So they have actually another large language model that decides whether it should be thinking or not thinking, okay? And so you'll see that as you ask it questions, either it spits out a question, an answer immediately, or it actually thinks about it first. Now, this is not perfect because, as you can imagine, it's very hard for OpenAI to decide this perfectly every single time. So you will see, queries where it should have reasoned, but it didn't, right? Or vice versa. Another one that's kind of been on the fore recently, kind of as of last week, is the Google Gemini models. That's another great default, and a lot of companies actually use Gemini because it is cheaper than OpenAI because Google is a huge company that's able to absorb some of the costs. And so a lot of people love the Gemini model. Anthropic is another company that is more expensive, but weirdly good at coding tasks. Okay, so you'll see a lot of software engineering companies will be using exclusively Anthropic for their coding tasks. Okay, so they've decided to kind of specialize in software engineering in particular. Okay. Grok, so Elon Musk Grok, kind of the butt of a lot of jokes, but it is starting to get very powerful actually, right? So they just released a model 2 weeks ago that beat pretty much everyone at benchmarks, right? So very, very powerful model. And why everyone's kind of shocked about that is because this team was only started 18 months ago. And so they've climbed the ladder extremely quickly, kind of almost Elon Musk style, to get kind of to the top of the pack, okay? So what should you kind of expect? All right, open source models. So the default that we often use is Qwen. Kimi is a great agentic model if you want agentic stuff. DeepSeek and Llama were kind of big names, but recently they haven't released much. So people have stopped kind of using their models. But when they release something, generally it's quite good. Okay, so those are kind of names to keep an eye out for. Okay, Open Router is another kind of useful thing to be aware of. It is kind of this website where it allows you to use whatever the cheapest available model is at that time, right? Kind of within a narrow range of capabilities. And what's also cool about Open Router is that it allows you to use mystery models, right? So a lot of companies will release models that they don't want public yet, but they want to test to see how people use them, right? And so these mystery models often are more powerful models from companies like Google or OpenAI. So you kind of get access to the latest models. In terms of benchmarks, there are two main benchmarks that we use in the field to decide which model we want to use. The first is this company called Artificial Analysis. So you can actually just Google that, right? It's a very useful website. It allows you to pick the best model if you want the most intelligent model, the fastest model, or the cheapest model, right? So depending on what you're trying to optimize for. And kind of fun fact, it's an Australian company as well. So these Australian guys in Sydney decided to put this website together, and a lot of people now use this to decide which model to use. Another important benchmark is LM Arena. So you can just search LM Arena. This basically provides a list, a kind of ranking of models based on what you want. So for example, if you want a language model, then this is the best ranking. If you want web development, then this is the best ranking. If you want images, this is the best ranking, and so on and so forth, right? So you can kind of decide based on what your use case is. So again, very useful. Okay, there's a couple of other fun benchmarks to be aware of if you're operating in this field. The first is, for some reason, this famous blogger decided to ask ChatGPT a while back to create a pelican riding a bicycle, right? And so it's become a standard test in terms of how well an AI can actually draw a pelican riding a bicycle, right? So famous test there. This one was the test I mentioned yesterday, which is called Snitch Bench. So that is a benchmark that determines how likely an AI model is to snitch against you with the FBI, right? So if you ask it to do something illegal, it will actually report it to the FBI, right? So yeah, that's kind of like a fun benchmark. And then another famous benchmark from a video perspective is Will Smith eating spaghetti, right? So this is a couple of years ago how it performed, and then this is how it performs now, right? So as you can see, video has improved quite a lot. Okay, so if you want to improve a model, so that is you're testing a model and it's still not good enough for your specific task, there are basically two options that you can do. The first is you can do this thing called prompt engineering. And so I'm going to get you to do that for about 5 or 10 minutes later. And you basically provide detailed instructions and examples inside the prompt itself. Okay? So this can extend to like many pages of examples and instructions, right? There's no kind of limit. You can even give it like a whole book of instructions if you'd like, right? A lot of people don't do that. But yeah, like this is one way that is very cheap, very affordable, and very fast to do. Okay, so you kind of want to learn how to do this. The second one, if prompt engineering is not good enough, so say for example, the task just happens to be quite hard for some reason, right? Such that you can't give it instructions and it can't figure it out. Then you turn to what's known as reinforcement fine-tuning, which is you actually modify the weights of the model to be able to do your specific task very, very well, okay? Now, why would this be used? Generally, companies have a bunch of proprietary data that they want an AI model to learn how to use, right? So for example, if it's a hospital, like they have very unique data that most LLMs have not at all been trained on, right? Like they've never seen that data for some reason, right? And so they would use reinforcement fine-tuning in order to train the AI for that specific task, which they find to be commercially valuable, okay? So this is much more broadly used in companies and very valuable for companies, while this is generally used for individuals, okay? Now this is kind of on the starting range of $500 to $1,000, but obviously you can spend way more than that depending on how complex the task is. Okay, prompt engineering. So prompt engineering occurs from this really cool thing called in-context learning, which is that we found that models with more than 100 million parameters can understand instructions and learn from examples. That is very important because as you can imagine, when we had neural networks, when we trained it to do a specific task, it could not do any other task, right? But now we have these models which can actually learn from the examples we give it and the instructions we provide so that it can do other tasks that we did not initially train it for, okay? Now it's very powerful because we no longer need to update any parameters for the model to learn. So we call this non-parametric learning because we no longer rely on parameters. Now, a classic example of this is when we ask, for example, the AI to classify the text into neutral, negative, or positive sentiment. So I think the vacation is okay. And then it responds with neutral. So this kind of setup here is called zero-shot prompting. That is, we don't give it any examples whatsoever. Okay, so we call it zero-shot prompting because there are 0 shots at the answer. Someone then decided to do what's called few-shot prompting, which is they gave it a task and then they gave it a bunch of examples. Okay, so for example, what a beautiful day. That is considered positive. The weather is quite bad today. The sentiment is negative. I have a desk in my living room. The sentiment is neutral. And they found that when they gave these set of examples, the AI ended up doing a lot better, right? Because it would actually learn from the examples. Someone also tried something called chain of thought prompting, which is when you give it something like a math problem. So, you know, Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? If you just simply state the answer, then the model is likely to get the next question wrong. But if you explain your reasoning, Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls, 5 plus 6 equals 11. The answer is 11. So that is, you explain how you actually reach your answer. They realized that AI was more likely to get math problems right. Okay? And so we'll talk about this more in a couple of slides. But this is the very foundation of reasoning models, right? So this is obviously a very simple example, but they realized that they could do it for increasingly complex things, right? They could just explain how they got to a conclusion for a scientific problem or a medical problem or whatever. And as long as you had this explanation, the AI would use that explanation to learn how to make its own explanation, okay? And kind of surprisingly, this is just 2022, right? So we're still trying very simple stuff with AI. And so this has kind of blossomed into a field of prompt engineering, whereby people actually add very complex and detailed instructions for how AI can improve, right? Now, have you guys done prompt engineering before? Can I kind of get a show of hands if you have tried giving really detailed instructions? Okay, to AI, kind of? Okay, maybe we can do this kind of example, maybe for about 5 or 10 minutes. Where I want you to work with a partner to prompt engineer an AI that is very good at history taking from a patient, okay? And just kind of think about what examples or what instructions you would provide. And what I usually say for clinicians who, you know, in our research projects want to do this as well, is that you want to provide instructions as if it's an intern or someone who's just starting out. What kind of instructions would you give them in order for them to do this well, okay? Now, in terms of like how insane this can get, right? This is a really kind of silly example, but people were trying to prompt engineer GeoGuessr. Does anyone know what GeoGuessr is? It's basically you have this image and you got to guess where this is. Does anyone know where this is, by the way? Very close, yes. Yeah. So, you know, someone was trying to go, okay, like, can I beat Rainbolt, which is like this guy who's very good at it, And they created this huge prompt engineer, right? Like this massive kind of message. And this is just like 10% of the message, right? And so they explain exactly how like Rainbolt does it. And it got really good at guessing where, you know, they would just upload random images, like even inside a house, and be able to guess like where that house is, right? Sorry? No, this is not a house, but like sorry? Inside a house, yeah, someone tried to put inside a house and it was like, well, that kind of architecture of the wall kind of feels like it's, you know, in this part of America, and it's like specifically, it's crazy, right? So with prompt engineering, you can do pretty crazy stuff, right? So give this a try for about 5 to 10 minutes, and then we can bring it back and kind of talk about the rest of the slides.
Earlier in my course, we had like 7 steps to like prompt engineer.
Yeah.
So I cross-checked with that.
Yeah. What were the 7 steps, or
so there?
What were the tricks?
Of course, first of all, like saying what's the situation, so defining the situation, then the task at hand, and then context and the role that he has to take with AI. And that's pretty much it, the main 3-4 steps.
Yeah. Well, those steps from the one of the founders of OpenAI.
I think.
By any chance? Yeah. So this is like a famous, like, let me just see if I can find it. It's like a famous kind of set of steps that one of the founders of OpenAI recommended. Let's see, prompt
And,
engineering.
and probably also Google.
Brockman. Yeah, so he said like this was the anatomy that he always used, right? And has found to be like ultra useful. Um, this one here. See? So it's like you describe the goal and then the return format, any warnings, and then context them, right? But people have even optimized it even further. So if you take a look at, the one that we had, it's like, you talk about like the role, like the instructions, what's allowed and what's required, right? And it will take a lot of this information into heart, right? And actually be quite good at following your instructions. Did anyone kind of find any other structures that they experimented with or kind of any other tricks to get the AI to do what it wanted? Yeah, so there's lots of like, it's kind of like the best way is to, as if you're writing a whole set of instructions for someone who is working for you, right? And has just kind of started. What kind of advice would you give to them, right? And kind of in our experimentations, it's not only just technical information that's quite good, but you can also deal with the soft stuff, right? In terms of how you should be asking questions, like what kind of, what kind of tone do you want with the patient or do you want with the user, right? Like setting that kind of stuff is, important, if not more important than some of the technical stuff, because it already holds some of that technical stuff, through its kind of knowledge, right? The tone you might want or like, the kind of character you might want is very important as well. And so that stuff can also be prompt engineered, equally well. So let's keep on moving forward so that we can kind of get to the end. So the kind of second technique that you can do, which is much more prevalent in companies, is something called reinforcement fine-tuning. And how it works is that you essentially train an LLM to complete a specific complex task, right? And usually it's with some kind of proprietary data. You need around hundreds or thousands of training examples, right? And it costs roughly this range. And it's generally better if you have some kind of reward function. So that is the AI knows that it's doing the right job, right? So that kind of signal is very useful. The package that most people use these days is something called OpenPipe, right? So OpenPipe is a very powerful way to kind of just do reinforcement learning, fine-tuning. And they recently just got acquired as well, so it's quite a good package. And a lot of companies just use this one. Okay, useful tools in the AI space. So the first kind of tool that you'll see is this thing called Google Colab, which is a notebook where you can write like kind of snippets of code and kind of run things very quickly. And so hopefully you'll actually use this and learn from this as well. So Google Colab is a very powerful way to run simple AI models, right? So for example, interact with OpenAI, but it is a bit restricted when you want to build something, right? Like something that is a full, complete software. And so at that kind of point in time, you need to start using this thing called vibe coding, which, the kind of default that we often use is a tool called Cursor, because Cursor has a very good educational plan whereby you can sign up and get free Cursor Pro for a whole year, right? And so we're going to teach you how to use Cursor because you're going to be using it in your projects. In terms of creating user interfaces, the tool that we recommend right now is something called Lovable. It is very good at creating user interfaces, right? So stuff that is very beautiful and easy to use. And then you need to kind of tie that back into Cursor to build functionality out of it. In terms of cloud compute, Google provides $300 in free credit for new customers, right? And so you can just sign up, create an account, you get $300 of compute, which is quite a big amount for a lot of projects, right? So very useful to kind of have in hand. In terms of data sets, if you want kind of like any special data sets, so for example, like clinical data sets or any type of data set, Hugging Face is the website that we all use because a lot of people will post open data sets on it, right? So if you want to do something interesting, for example, in a specific field, Hugging Face might have a data set that suits exactly what you want and need. In terms of tools, so a lot of AI agents use tools. The kind of thing that most people use right now is this protocol called MCP. So you can just simply search MCP tools, and then you'll get a bunch of stuff that AI is able to use, right? And that includes, things as innocuous as like getting the weather in a certain place or, checking the price of something on Amazon, right? But it also includes some medical stuff as well. So I believe you can retrieve like a bunch of papers and then read what's in it, right? Or do kind of stuff that's a bit more scientific. In terms of deployment, so once you've built a solution, the kind of software that we consider when we want to deploy a website, although we don't expect you to deploy a website for this competition, is things like Heroku, Vercel, or Flyer.io. I personally just use Heroku because I found it's easiest and cheapest, but if you want to kind of deploy something online, that's kind of how you do so. So you need to use a different software once you build something to deploy it on the internet, right? So that everyone else can access it.